In this video, I'm going to talk about slope fields a little bit more than in the first video, and just seeing about how a curve might fit a slope field. So a slope field, like the one shown on the screen here, it's really like a graph of a first order differential equation, right? So this particular slope field is this g of x comma y is actually dy dx. So you can think of that as dy dx, and it equals that y plus x. And so the idea is that the slope at any point in the plane is equal to the y coordinate of that point plus the x coordinate of that point. It's called a differential equation because if you watch video number 1, you'll see a little bit more of a description of what those are, but it's an equation that has the derivative, y prime or dy dx, as well as x and y in it. You can also have differential equations with second derivatives and third derivatives. Those would be called second order or third order differential equations and more. But a slope field is specifically for a first order differential equation because dy dx is the first derivative, and you can only, like the slope field just shows those slopes at every point. So it's not showing the, like the second derivative behavior or third derivative behavior. So there's a green curve through this slope field right now, and that green curve is one solution curve. The idea is the slope field shows all of the solution curves, right? When you have a differential equation, when you have an equation with like y prime or dy dx in it, it has infinitely many solutions. That's why we get a plus c when we're integrating. So this slope field represents infinitely many different curves. One of them is shown by that green curve. So what I'm going to do is move this slider to move that green curve through the slope field, and you can kind of see how it fits. But first, look at how it is right now. Whenever the green curve is near a hash mark, it's going through it with the same slope. When it's a little further from a hash mark, it's going to be a little bit off because it's not at the same slope as that hash mark. So right here where the cursor is pointing, the green curve is passing between these two hash marks, and notice the slope of the green curve there is somewhere between the slopes of those two hash marks. When the green curve is passing really closely to a hash mark or through it, it looks like it's actually going through it with the same slope. In the slope field, when it looks like the slopes change from, when the hash marks change from decreasing to increasing, so negative slope to positive slope, somewhere in between there's probably a zero slope point, right? And so you can see along this line here, it looks like there are zero slope points in there somewhere. And in fact, that's something we'll look at later in this unit. And you can see on the green curve, there's a minimum there where the slope is zero. Where that's happening, that would be where there would be a zero slope hash mark. The slope field only shows some hash marks. They're everywhere though, right? You could do it anywhere in there. You could do as many as you want, as dense as you want. If we tried to show all of them, you wouldn't see anything. It would just be a blob of hash marks, right? So we just show them at certain intervals. So as I move this cursor, watch how the green curve moves. Wherever it is, it should always have that behavior where it's either passing through the hash marks that it's closest to, or as it's passing between them, it's got a slope between them. And then over here on the other side, same thing. Same thing is happening. Okay, so you can kind of see these different solution curves as they interact within the slope field. One of the things that you're asked to do sometimes is to sketch a solution curve through a slope field. So what that would mean is you're given the slope field like this without the solution curve, and then you're asked to sketch a solution curve, let's say through this point right here. And so if I'm just doing it by hand, I start at that point and I just kind of, it's like a fancy connect the dots. You just kind of go through, you don't have to hit the hash marks. It's okay to go between them. It's also okay to hit them. But if you're going through a hash mark, it should have the same, like your curve should have the same slope as that hash mark, like right in the center of it. And then if you go between two hash marks, you should probably be between the slopes of those hash marks. So let me turn back on the green curve and pretend that I'm sketching this. So what I would have to do is find, I'll have to, since I'm moving the slider, I'd have to find a C value that would hit that black point just right. And I don't think I can do it with the slider just by sliding. So I'm going to try testing some values here. If I do like 0.5, 0.4, 0.2, thank you. 0.1, oh, 0.1's pretty close. Let me do 0.99 or 0.95 maybe. Oh, I'm going the wrong way. Oh, it's 0.1, 0.09. There we go. 0.08. Anyway, you can see that now I'm pretty much through it. So that's what that solution curve should look like, passing through that point. If you're hand drawing it, it doesn't have to be perfect. It just has to have these kind of characteristics. It should be pretty close, right? But if you hand drew this, your curve might end up a little over here maybe, or maybe, somewhere in there. But it might not be in exactly the right spot out here because this is an exercise in estimation. But it should never be crossing over a hash mark at like a different slope or anything like that. Okay. I'm going to look at one other type of problem. So that's the slope fields, what they look like, how the curves fit through them. Now I want to look at one other type of problem, and if you're in my class, we'll do some of these in class as well. But AP exam problems tend to look like this. One of two things. They tend to either give you a slope field and ask you to choose the correct differential equation for that slope field, like this one, or they give you a differential equation and ask you to choose the correct slope field to match the differential equation. So those are very common AP exam questions. There are other things you can do too with slope fields on the AP exam, and but these are very typical. So let's look at these two questions is all we'll do, and then it's got to save some for you to try on your own. But if you think you know what to do, pause the video, try to figure it out, and then come back. All right, and if you need a hint, listen, because I'll give a big hint first, and then pause the video if you think you got something, and try to solve it. On this one, there's some features of this slope field that jump out at me. Maybe they jump out at you too. One feature that jumps out at me is right here. I have a bunch of horizontal hash marks. It looks like it may be x equals -1. That would be maybe my guess, somewhere around there. So I'm going to say x equals -1. Slope equals 0, right? But also, these are all horizontal hash marks as well. So it also looks like y equals 0. When y equals 0, the slopes are 0. Well, what that means is if I have dy dx equals, right, then I need the other side to equal 0 whenever y equals 0. And whenever x equals maybe -1, maybe, it's not like it's scaled out on there for us. So maybe it's close to -1. Maybe I'm misreading it, but it's -1. So yeah, like basically factors, right? If you look at the factors of these, do they give me, y equals 0. What factor do I want there? Well, that's just a y factor. And then for x to equal -1, to be a 0, then I need x plus 1 to be a factor, right? So basically, I'm looking for those two factors, y and x plus 1, to get those 0 slopes. And so that's what I'm going to look at on here. Where do I have those factors? And A is already factored. It's got x and y, not x plus 1 and y, so it's not that. So I'm just, process of elimination too here. B is, if you factor out a y, it leaves you x minus y. Oh, sorry, not that. It leaves you x minus 1, which is also not right. That would give me zeros at y equals 0 and x equals +1, not -1. So it's not. C, ooh, that looks promising. Y, and then x plus 1. Those are the two factors I was talking about. So that one looks good. But don't just assume you're right. Okay, it's possible that two of them could have those factors, and then there might be another distinguishing factor that makes one of them right and one wrong. So you do want to kind of go through them all if you have the time, and make sure you've got it. So the next one, if I factor out an x, then I get y plus 1. Well, that's not it, right? That would be y equals -1 and x equals 0, so that's not it. And then the last one would only be when x equals -1. That factor is cubed. When you get a little more advanced with these, you can start to look at the difference between if you had something like this versus just x plus 1. Maybe you could think about it now even. Those sometimes do show up, stuff like that, when it's a little bit intended to be a little bit more of a difficult question, but here it doesn't matter. The x equals -1 is one of the things we wanted, but the y is not there. So the answer to this one is indeed C. All right, so using that same logic, let's look at the next one. And similar ideas here. Now you could look at all the different slopes and do what we just did, but that's 5 different slope fields. Let's look at the thing we have one of. And think about what we did, right? We factored those differential equations, and we knew where the zeros on the slope field should be, those horizontal hash marks for zero slope. And so we can do the same thing here. If you factor this, again, pause it if you think you know what to do. Pause it, do this, and see if you can figure out the answer, and then listen. So when we factor this, you're going to get y plus 1, y minus 1, right? Difference of squares. And that gives me dy dx equals 0 at y equals plus or minus 1. And so I'm looking for horizontal hash marks across the slope field when y equals 1 or y equals negative 1. And only one of these graphs looks like it has that. Right about here and right about here. Now you might be thinking, well, those aren't quite horizontal. They're close, but they're not exactly horizontal. And I agree, but the thing is, even though there's some scale there, negative 2, 2 on both axes, there's no like tick mark shown for it. And so I don't know that this line where these slope lines are shown, I don't know that that's exactly y equals 1 and that that's exactly y equals negative 1. In fact, I'm going to say it's not because those slopes are not horizontal, right? So it's probably just a little bit above y equals 1 here, and it's probably a little below y equals negative 1 here, and that's why they're just a little off. But that's the only slope field that seems to fit this. The other 4, they don't fit it at all. In fact, 3 of them, B, C, and D, if you go across a y value, the slopes are changing. That wouldn't happen with this differential equation because our slope is based only on y, right? So if you plug in any one y value into this differential equation, it's going to give you the same slope all the way across. That doesn't happen with B, it doesn't happen with C, and it doesn't happen with D. So if you notice that right away, dy dx is in terms of y only, you can immediately rule out any of these slope fields that change slopes as you move horizontally. The only way that you're going to have slopes change as you move horizontally is if there's an x in the definition for dy dx. Now, E does have this characteristic. When you look at any horizontal line, the slopes are staying the same. Okay. By the way, that same logic can be used with vertical, and it's dy in terms of x only. So if you see some problems like that, we can do that too. Anyway, though, E has that characteristic, but E does not have the zeros where we want them. If you look close to y equals 1 and y equals negative 1, it's not close, right? Here, they're not close to horizontal, whereas here they are. And you could also look at the signs of the slopes in different places. E looks like it changes signs of slopes when you cross y equals 0. That would not happen here because the only y in it is squared. So there's a few reasons we could rule out E, and A is definitely the only possible answer to that question. So hopefully that was helpful. There's more to come in some future videos.